Alright, now if you've watched all the limit videos leading up to this, and if you're going to watch the rest of the videos after this, then this video is going to be a little bit redundant, but just because this is a question I get so often from students I tutor in person, I just wanted to really just beat you over the head with it because it's so important. It's not important in like the big capital I important sense of life or anything, but just on your limits tests and quizzes, there's the kind of little nitpicky detail and the type of question that could kind of like haunt you a bunch of different times. So that's why we just got to be really clear about when does the limit exist, when does it matter that the two coming from two different sides matches, and when they don't match, and all that kind of stuff. And also, what's the deal with infinity? All right, well, let's take a crack. Like I said, this should be a review if you've seen my other videos, but if you haven't, man, this might really be just what you're looking for. All right, so these are arbitrary rules. I don't know why they're this way, but whatever. It's just how it is in every calculus class. So rule number one, infinity is not a number. So a lot of times, and I get this question from students all the time, they'll say, well, hey, 5 over 0, why is that undefined? Why isn't it just infinity? And the reason is because infinity kind of isn't a number. So infinity is the idea of a number that's getting bigger super fast and will never end. And they call that increasing without bound. But the point is, it's not a number. It's not like a jillion. Because if you try and, figure out how many, 5 divided by 0 is saying, hey, how many times does 0 go into 5? So you could start putting in zeros, right? You could put in a jillion zeros. But even if you put in the biggest number you could ever imagine times 0, you're still just at 0. You haven't even made a dent in getting to 5 someday. So that's why it's not just infinity. There's literally no number that is even the same league as 5 divided by 0. It's just undefined. So that's why it's not infinity. So infinity is not an actual number. Infinity is the idea of the biggest thing ever. And I know that sounds like a nitpicky detail, but that's how mathematicians are. And throughout calculus, whenever like infinity might have been a good thing to write down, what they'll instead do is some little legalistic trickery so they don't have to actually have to write down the number infinity. So infinity is not a number. If you ever get something like limit as x approaches 0 of 1 over x, where you're pretty much going to be getting 1 over 0, you're not going to write down infinity. You're going to write down no limit or does not exist. Same thing here. Plug in 2 for these guys, and we get 4 plus 2 is 6 over 2 minus 2 is 0. So once again, 6 over 0, undefined, but if you're talking about the limit, it does not exist. It's not infinity. Except what's crazy is that there are other times, like on one-sided limits, where it might be okay to write down plus infinity for basically shooting upwards along an asymptote, or negative infinity for shooting down along an asymptote, a vertical asymptote. And you might be able to write those down, but that still doesn't exist. All that's doing is describing whether the thing shoots upwards or shoots downwards, but still infinity not a number. So if they're asking what's the limit, the answer is does not exist. If they're asking does the left-sided limit match the right-sided limit, then the question is, are they both not existing in the same direction, or is one not existing upwards and one's not existing downwards? And that's what this plus infinity minus infinity business is. But still, the limit does not exist if you're dividing by 0, ipso facto. All right, arbitrary rule number 2, and it's the one we've already beat a little bit over the head in the previous video, which is the left and right have to match. So in this particular case, if we're trying to find the limit as x approaches 2 on this left-hand graph, what you'll notice is, and the key point is that if we approach from the right, so we're coming from this direction on a one-sided limit, and if we drove simultaneously from the left, so we're just going down this line from either direction, they're going to hit in the same spot, right? If this was 2 cars driving down that road, the 2 roads line up, the 2 cars are going to collide head-to-head. It turns out that when they collide, there actually won't be a point there, because the point was like, haha, see, I'm up here. It's like some trickery that there was actually no point there, but there was a point there. But the point is, right before they got there, they thought they were going to collide right there. So that's where the limit is, and that limit exists. So if you're asking the question, hey, does the limit exist at x equals 2, as x approaches 2 for this left-hand graph? You'd be like, yeah, it does, because if you're riding along f of x, it looks like you're going to have a head-on collision. They meet up really nicely, so that limit does exist. Whether or not there's that other dot somewhere else, the point is that as they're coming from the two sides, the limit exists because they line up. But on this other graph, if we were driving along the right, coming in like this, coming from the left, we're coming in like this, and these two are not going to line up. They're going to fly right past each other, right? So when they come to, as we take the limit as x approaches 1, it's going to go like this, and they're going to end up parked with a pretty good amount of distance between them. Those do not match up, therefore the limit does not exist. There is a limit from the left, so like the limit from the left here, as I described in one-sided limit video, the limit from the left exists. It looks like it's 1. The limit from the right exists because it looks like we're headed for this point, which is at y equals 3. So the limit from the left is 1, the limit from the right is 3, but the limit at 1, as x approaches 1, without saying left or right, just the limit as x approaches 1 from both directions, does not exist. So that's that key thing where if x was approaching 1 from the left, this would be the right answer. If x is approaching 1 from the right, 3 would be the answer. But if x is just approaching 1, so it's a limit as x approaches 1, does not exist because the left and the right don't match up. All right, so once you get a bunch of practice, and always check your answers in the back of the book, hopefully this will sort of help you figure out why maybe you're getting some wrong in the back of the book. So there's a lot of ways to get a DNE. If you divide by 0, that would give you a does not exist for your limit. But also, even if nothing shoots off to infinity, you can still get a does not exist because the left and right just don't match up. There you go. That's a little bit of the legalese of limits, and stick around for more exciting limits videos.